It's World Cancer Day. I wanted to introduce you to a researcher at the cutting edge of research into this disease. Dr. Julia Bernier is a scientist at the Research Institute of the McGill University Health Center and is on the line. Good morning, Dr. Bernier.
Good morning. Thank you for having me.
So, how long have you been in cancer research?
Oh, a long time, dating back to my PhD at McGill in the early 2000s, but I've had my lab set up at McGill for the last 4 years.
So what kind of progress have you seen, this is my point, in the last 20 years, say?
There's been a lot. You might have heard the term precision oncology, and I think that's really what the progress has been reliant on, is the idea of targeting very specifically cancer patients using targeted therapies, using modalities that are really targeted to specifically kill the tumor cells of a particular patient, and that has been really evolving over the last 20 years.
Are there cancers that used to be pretty well a death sentence that are not anymore?
Absolutely. One good example, is in the early 2000s, chronic myeloid leukemia. Researchers found the gene fusion, the Philadelphia chromosome that was responsible for the disease, and imatinib or Gleevec was a drug that was used to target it, and it really improved drastically the outcome for patients with that disease.
What made you want to get into cancer research?
I think it's a disease that really touches everybody. It's an incredibly heterogeneous disease, a very complex disease, and really I would say it's many different diseases that we call cancer, and studying it brings a lot of impact to particular patients and their quality of life, how they live with the disease, and ultimately how we can improve mortality rates.
Okay, and we are improving mortality rates, are we not? We are.
There's still a lot of work to be done, but certainly we've made tremendous progress in specific cancer types, and particularly the goal is, of course, to cure and to eradicate cancer, but also I think huge improvements have been made in how patients live with cancer, the quality of life of patients while they're on treatment, and that has been, I think, instrumental in this fight against cancer.
How many different types of cancers are there? I mean, you like when we always just say cancer, but as you mentioned, there's many different kinds.
Yeah, I think it depends on the level of granularity that we talk about.
Yeah.
Different cancer by organ, breast cancer, colon cancer, brain cancer. But even within each disease, it's really amazing how many different subtypes. And we're learning about that, and we've learned about that over the last 20 years because of gene sequencing and our understanding of how different, for example, breast cancer subtypes behave very differently from one another. And the characteristics of the cancer cells in different subtypes are very different, and that also means targeting them with different approaches.
I want to know where you grew up and went to high school and what you were like in high school.
I grew up here in Montreal. I'm from Brazil, but I grew up in Montreal. I went to the study, and I've always been keenly interested in science. I had a wonderful science teacher, Mr. Lochte, in high school who really got me excited.
Yeah, that's amazing. That makes all the difference, I guess, for people like you who go into that field. Yeah,
absolutely.
Yeah. So tell me about your fundraiser today.
Well, today is World Cancer Day, and the idea is really to shed light and emphasis and importance on cancer and cancer research. So the MUHC Foundation is partnering with lots of researchers to try to raise additional funds for the work that we do. My lab works on something called a liquid biopsy, which is a non-invasive way to monitor cancer. We take blood samples or other biofluids, and we look for fragments of DNA that come specifically from tumor cells, and we can use that to monitor patients to see if they're doing better, if their disease is progressing, how they're responding to treatment, and it also gives us a really powerful tool to understand the biology of cancer, which ultimately will help us to design better therapies.